We good? Oh, it's bright. Yeah? Okay. Hello. Okay, there's some people here. It's a really long day, I guess, and many big ideas to absorb. I'll try to stick with small ideas for the rest of this to make it easier to digest. There's a 40-meter drop here. Okay, so, this is the end of the festival, right? This is the last piece of content. Okay, we're going to have a thank you to everybody, or do I have to do that? Thank you to the festival team for such a wonderful festival. This was a very tough thing to do. The experimental nature of the festival was much more progressive than usual, and yet it was performed in an institution which had never worked with this type of content before. I can say how hard it's been for a lot of team members to get it all together and put on the stages what you've seen. So I really want to say thank you to everybody from the teams of the festival. Okay, so we are an art studio called Kimchi and Chips, and we make works usually within this kind of light, space, technology combination, right, this set. And there's two people in the studio. There's myself and Mimi-san, and Mimi's not here at the moment, and also we don't talk together. We don't give presentations together. We find it's much better when we individually can prompt the audience into a certain set of thinking and discuss within that set, which requires that we don't overlap too much, because otherwise we'll end up displacing each other's dialogues. But what I would say is then that the presentation I give today is from my side of the storytelling. It's not the entire story of Kimchi and Chips. There is another story to tell also. Sorry. So this is our space in South Korea. We have a studio in Paju, which is about 40 kilometers out from the capital. And this is just a space for experiments, designs, preparation, planning. Obviously, we don't produce the larger physical things here, so we have a separate space for that. So we have a factory that we share with a fabricator, and other artists also use this same space. There are professional teams who do tasks such as welding or electrics, and anything that involves manipulating large, heavy things is also a professional task that needs people with skills in that realm. So here is when we were preparing Halo for the exhibition that we had at the National Museum of Contemporary Art that opened about 2 months ago. Can I actually get in here? And you can just see another artwork here that's being prepared also. So, as you might have caught from the outside work, often our artwork deals with scale. It deals with putting a body into a space which is immersed in a set of technologies which we've developed. And as well as the spaces, there's also team members. So we don't have a very big team. People join for projects. So here are the assembly team that was involved in building the modules for outside. So these are all the lasers which were installed outside. So we started in 2010, and we weren't really taking it too seriously at the time. We called ourselves Kimchi and Chips. We wanted to make something a little bit different than what we were seeing around, and maybe a little bit poke the patterns that we thought people were taking for granted in our relationships with technology. So in 2010, this was the year that the iPhone 4 came out, and it was the first iPhone with a selfie camera. It was also the year that the iPad came out. And we wanted to make an installation about this emerging photo play that was happening in cafes. So many people would go to cafes and spend a whole day taking photos of each other, and it was a kind of an emerging phenomena, right, which then became like selka, which became selfies, or, well, selka is still a Korean term. So here was a way in which people could play with the cell cap, but also then become part of the installation. So there's a interface where people have a kind of expanded version of the cell cap, which is basically an iPad with a camera attached, and then they record themselves and then they become part of the installation. And the intention was quite simple, that we wanted people to get out of the mode of audience and presenter, that things would flip around if people became part of the installation to start with. And then we also have like a series of works which we call Drawing in the Air, which are about making images in physical space. So you'll see a little bit about our work relating to image formats throughout the presentation. This is a very early one, where we have a tree, and we project into the tree with a video projector, and then we scan in the 3D location of every single pixel. So we end up with a cloud of pixels in space, which can all be addressed and turned on and off. And then we can create 3D forms using those pixels in space. But the secondary effect of this is that the light is also releasing hormones in the tree. And those hormones then change the shape of the tree. So over the duration of the exhibition, the light where it's been projected will have an effect on the growth of the tree. And then we invite the audience to participate in this process also by, you can scan your hand and have that projected in this 3D form inside the tree, which then releases the hormones there. So a lot of people think that we're a commercial studio. And we haven't actually been involved in branding projects. We don't make adverts and then come back and make installations. We don't have this symbiosis between commercial projects and art projects. But we tried. We've pitched for all of these things. We've pitched for casinos, trainers, mobile phones, anything. Maybe our moral standard was exercised by the fact we failed in all of those. But anyway, I think the way of existing works differently for different artists, and for us, it hasn't worked out with commercial projects. So we're not really in that domain. Anyway, my background is in physics, so I didn't study art. I've never had a formal arts education. I'm always playing catch-up. I feel like people are ahead of me in terms of their skills at communicating their work and positioning it within the dialogue. Instead, my background was in being a technician, understanding materials, understanding energy dynamics. But anyway, I started to be a little bit disenchanted with the notion or the attitude of physics, of modern physics. So if we think back to the kind of Enlightenment era, where we had Descartes, Newton, and they had this idea of okay, I think therefore I am, and this is this ground piece of information, and then you add things onto it, and then you can build up a worldview using this, right? This is kind of the way physics worked. So it looks a lot like this model, right? Where we have a kind of a founding idea, and all we can do is just add and add and add to that, right? And we're trying to just make this ball bigger and bigger and bigger. And if you have a PhD, then what you're doing is you're kind of adding something onto the ball of knowledge, which then expands for everybody, right? But as the ball gets bigger and bigger and bigger, everyone's individual contributions get relatively smaller and smaller. And we end up with these massive physics experiments like the Large Hadron Collider, which, although they employ people and have all these other effects which are positive, the kind of primary interest of discovering a particle has relatively small influence on human life compared to something like discovering optics, discovering calculus. This is things which were early on in the ball. So I think for me what's interesting about art is it's about making packages of logic around ideas, investigating them, exercising them, and those don't have to come as this growth exactly on something that already exists. They just have to make sense by themselves, and then you can see does that make sense to bring back to like this common worldview? So I'd like to talk a bit about like, well, what is a worldview? Like, what does it mean to have a worldview functionally? So our eye is one machine of perception, right? There's like stuff coming in, and we think about it, and we have a conscious experience. So let's think about like how this works. It's a kind of a compression of information, and it comes down the optic nerve, and then it's an expansion of information. So that compression is you selecting what you're looking at and what information you're going to pass to your brain, and that expansion is your imagination, the way you add to those things in order to fill out the gaps, in order to be convinced that you have a full conscious experience, that you're seeing everything. But the optic nerve in the middle is this very, very tight connection. And if some of you were at Retune Festival, you might know the answer to this question, but we're going to play the game of guess the bandwidth of the optic nerve, right? So the first number is dial-up, where we had like real player. So we're trying to guess how much bandwidth is coming down the center part here, right? Does anyone get this game? It's really hard to hear anything, see anything, be alive in this room, actually. It's really tricky. We're going to try and guess how much bandwidth is in the optic nerve, right? Number one is dial-up internet. Number two is Blu-ray, which is 128 megabits a second. And number three is this cable here, which goes to the projector, which is 18,000 megabits per second, right? So our instinct, I think everyone's so tired and maybe not going to actually play the game. But Joni, maybe you could play. People join in. Who thinks the bandwidth of the optic nerve is like dial-up internet? Okay, some people. Who thinks it's like Blu-ray? Okay, a couple of people, two. Who thinks it's like mega? Okay, we've got one. Got two. It's 222. So the right answer is 0.01 megabits per second. Right? That's the bandwidth of data that comes to you. So you can start to understand that, like, what is your worldview? It's this drastic compression of the reality into a description which you find valuable to yourself, and then the imagination around that description. So I think like you can think that some art is designed in order to maximally activate the network based on your prior conditioning, and some art is designed to not be describable by a preconditioned worldview. That if you have this system that's conditioned on everyday life, you put this new thing through it, and it doesn't make any sense. And therefore, in order to catch the artwork, you have to get this new thinking. So you present phenomena to the audience which falls outside of the type of things they would see, type of things they would observe. It's not just maximizing what you know is already exciting, it's exciting something which maximizes the change that happens in the worldview. So based on that, I had to think about what kind of work I wanted to be involved in. And I found that like work on screens has this contradiction. There's one is like you can do anything. You can put anything on a screen. You can build any world on a screen. But at the same time, all images on the screen share the same types of restrictions, that the screen itself has this implied or implicit nature to it, that it only describes images in a certain way. So based on this, a lot of our projects are around critiquing image formats, existing ones, or creating new image formats. And as mentioned yesterday, an image format is like the way in which something imaginary comes into the real world through an image. And the set of image formats that we use, be them mobile phones or drawing on a piece of paper or taking a photograph, like those formats change the way we imagine reality, because the passageway between the physical world and imaginary, being images, changes what we imagine here, right? And then it ultimately then changes what exists in the material world. So the first installation, perhaps I'll show which works in this, is called 483 lines. I'm going to see what happens if I just turn the volume up really loud. Nothing. Do I not have sound? I should have sound. You can hear it? Do I have sound from the laptop? Okay. Strings. Each string is tensioned to be almost perfectly straight across the gallery. So there's a tennis racket tensioner that's used to ratchet up the tension for every single string. This is a representation of the way that images were made in analog television. So in analog television, the image wasn't made of pixels, it was made of these horizontal lines. Right? The same way you had like a track on a vinyl record, the image on a television screen was a track that kind of spun across the screen. But every image format, it tries to display something, but it also displays its own nature. When you get close to a television screen, you kind of feel it falling apart. Sorry. And we wanted to make an installation which kind of echoes that phenomena which happens like when the television screen starts telling you about itself. And this was the goodbye to analog television, the same year they were switching off the analog broadcast in South Korea. How am I for time? I might skip or maybe go with this one. So we talk about images and we talk about something being imaginary, but what about something being physical? Can we start playing around with the idea of like whether or not something is physical? So we try to think about if something has a surface, does it make it physical? Even if it doesn't exist at any particular moment in time, perhaps by having a surface, you can think of it being a physical object in space. So this installation was set in a post-industrial building in South Korea, an incinerator where they used to burn the trash. There's a 40-meter chamber in the center, concrete chamber, where all the rubbish came in, and they wanted to make this into an art center. So we wanted to make this installation, which was a kind of rebirth of the space into its new role. And the way this works is we have this flag of fabric, this surface, which passes through space, and we have a 3D camera that's tracking it, watching the fabric. And then we video project back onto the fabric, wherever that is touching an imaginary moon, which exists in the bunker. So here is the line of light, wherever there's a contact between the imaginary sphere and the fabric. And if we take a long exposure image, we start to see the actual full moon appear, right? There's a surface which is traveling through space, and then it renders this thing to become physical. And we can see here, if we use the stills mode, you get a clearer version of it. And then we wanted to invite the audience to try to do this for themselves in their head, to kind of add together the image up using their eye, rather than do it with a long exposure camera. Because it was a building used for all of the trash, it wasn't a particularly nice building to be in. It had a very strong smell to it and really bad air, And again, we were trying to play with this idea of rebirthing the space or repurposing the space, being a part of the ceremony of rebirthing it. So we brought this tubing to bring in air to push the fabric. So in order to paint the sphere, now we could do it with this air from outside. So during the duration of the exhibition, 20,000 tons of air were pumped into the building. And as you came to see the exhibition, you could feel literally the building, the air in the building changing. That the smell was kind of shifting as you were standing there. Mm, 25, 6. I might skip light barrier and go to halo. So, we've been developing these techniques for drawing in the air, which often involve like an overlap of beams, trying to have some material, which is like fog or whatever, and by creating a density of light in the center, you can create an image where that overlap happens. And so an example project is light barrier, as mentioned. Some people might already be familiar with this project, so I might not spend too long talking about it. But the way this works is we're trying to see what makes something physical. This notion of the light barrier is the difference between something being light and something being material. If something is material, then it can't act like light because of the light barrier. And if something is light, it can't slow down. It always has to travel at one speed. So here we're building up these objects out of light. By using many calibrated video projections, we can build up a density of light in the air, and then that's kind of rendered as an object. And this can flow around in free space, making it into a new type of image format. Skip forward a little bit. Each of the mirrors individually is like a projector splitter. So if you think about like the video projector that's coming in now, like if I had a mirror here, like the pixel that hit here would bounce off in this direction, and the pixel that hit here would bounce off in this direction, right? So I can actually take a part of a projection and make that into another projector. So here we have these mirrors which split 8 video projectors into 400 video projectors. So we can have light coming from 400 different locations, but then all arriving at the same point in space. Okay, I've got 2 more minutes. So I'm going to cheat, though. I want to talk about a new project. Last time I was here at Retune, last time I was with the team at Retune, thank you. We talked about another moon, and then later that came into reality. This is a project which also we haven't made yet, and this isn't a pitch. This is a disaster. This is one which we kind of made, but it didn't work out. But instead of letting the corpse rot, I want to grow some flowers in it and see what happens. Obviously, a lot of people have been thinking about notions of structure, and in our work, we often think about that from a very technical perspective, that like literal structures, how to hold things up, how to make things move or stick in a place. So the earliest structures were this kind of like natural materials which were limited in terms of how big you could grow them. And then obviously with the Industrial Revolution, we got steel, and this was this new type of structure. And it also created new industries which in themselves had new structures behind them. So the first steel constructed building was this, the home insurance building in Chicago. And it was the first building where instead of building, stacking materials on top of each other, like you would do with bricks, instead you built a skeleton out of steel and you hung the building off of it. So it was the first building that used this definition of structure. But similarly, inside of it is banks, insurance companies. The birth of capitalism was also happening at the same time. So it was also the birth of a new type of structure, like happening in parallel. And now our structures are coming out from technology. Like our structures are made in smart contracts, AI trained systems, and they're again difficult to evaluate. When this building went up, people didn't understand it because you couldn't use any of the instincts from the past to consider how does it hold up and what are the connotations of it. And again, like our tools from the past to think about our previous structures don't apply to our new types of structures. And we also know that like the fact that structures necessarily are things that persist over time can also be problematic. So this is this notion here from James Bridle of colonial cabling, where you can trace the undersea cables and see the trade routes from colonial era echoed in modern times. Now, when we talk about structure, like often we use this tools called structural analysis, right, in like the technical realm, where we like measure the internal forces and stresses of something. But there's other reasons why buildings collapse. Right? So this is the Samsung department store in Seoul, South Korea. In 1995, the building collapsed as a result of the mismanagement, corruption, and the other structure that was existing inside the building. That it wasn't a case that the analysis was wrong, it was the case that the other half of the intelligence of the structure was wrong, the internal structure of the administration of the building. And these were enormous tragedies that had a huge effect on contemporary Korean culture. 500 people died, 1,000 people were injured. A year before, a bridge collapsed, and 50 people died in that incident. So what you can do is you can see the attitudes around structure in Korea when you look at the public buildings. So this is the Seoul City Hall, and there's definitely a feeling that people want to see the structure. They want to see that things not going to fall down, right? They want it to be, I'm going over the 2 minutes. They want to see it, right? They want to make sure they can see the structure. Anyway, we had a commission with a chaebol, which is a big Korean company. The chaebol literally translates as rich family. So this is Samsung, LG, Hyundai. And they're obviously very patriarchal and they're very hierarchical. So we wanted to make an installation which would a little bit twist around their notions of structure. So it was a structure which would have to be self-aware, and that every single point in the structure would have to move in response to the rest of the structure. That there was no top block that could determine the shape. The whole thing had to be performed with analysis, with intelligence, with sensitivity to everything else that was happening in the structure. Simultaneously, the project was doing that in an administrative way. We were trying to change the way the organization worked. So for scale, like the installation was 4.5 meters tall, around 3 tons in weight. There's a servo motor system inside each of these blocks, using the same level of safety you'd use for a nuclear power plant, so to make sure that it wouldn't collapse. If any point, any of the joints do the wrong thing, it would fall over. It always has to be knowledgeable about itself in order to not fall over. That in order for the structure to persist over time, it would have to adopt a new type of sensitivity and intelligence. So we developed our own tools for analyzing structure in this kind of traditional sense of like looking at the internal forces. So this was the first try of like making a structural analysis piece of software to think about how this thing might feel, how its internal stresses might be. And then we developed this into a kind of animation package where you can give the structure intentions. So you can say, okay, I want you to move just this one bit from here to here. Something really simple, a really simple intention. But in order to do that, the whole thing has to change because everything has to be happening in sensitivity to everything else. The project failed because they didn't believe that structure works like this. They believed that actually what we need to do is just make the bottom really strong and then make the top really smart. They didn't imagine that an artist can actually understand engineering. So they had other engineers which overruled us. And ultimately, the way in which they were trying to propose to do it, we knew wasn't safe, so the project didn't happen. But that was a little story I wanted to tell you. Like I said, I think that it's interesting ideas in there which could come out. And all of those things are on our GitHub, so you can see any of the behind the scenes of those works in code format. We also are involved in like running music festivals and conferences in South Korea, and always interested in trying to promote the work of others as well. So I just put in here a selection of other artists from South Korea, which you can have on in the background while we do our Q&A.
Thank you so much, Elliot Woods. It was
it's
great.
so hard in here,
It
isn't
is
it?
hot, yeah, it's true. And we need to get
think
out
the
and see
acoustics-
your installation now.
Ah, yes.
You know, this is what I'm looking forward to now. But who wants to ask a question? I have one, but there were so many people. Please don't be afraid. Just go to the mic. I don't ask you anymore because we can't check the iPad anymore. That's why. Otherwise, tomorrow again, we are here again tomorrow, and then please place some questions in the chat. Okay. You know what I was impressed of is that you make so much use of a material, physical material. This is like your passion, I feel. Yeah, you really try to try out materials in different ways. But we are here at the Festival of Digital Arts,
Yes.
and we are talking a lot about virtuality. So why is haptics? I feel you think haptics are very important. Why is it so important to you? Why are materials, physical materials, so important to you?
Well, we always try to work with like simple ingredients. So, I mean, on the screen right now, oh, not on the screen. Let me bring up Halo. So Halo is this work where we had an array of mirrors which bring sunlight together and they create an image in the air. And here, the materials are very simple. It's sunlight, water, mirrors, everyday materials,
Yes.
right?
The children play with.
And materials have instincts around them. If we can show that something fantastic can emerge from what you're used to being in your everyday, it helps you to reconfigure your instincts about your everyday life. We're keen that we're not showing people something which feels like distant magic, where there's a black box and it's got inside of it some like complicated electronics which like you can't really catch, like there must be something happening in there. Like actually not very keen on that. We don't really like that, especially when we're trying to help people, when we're trying to bring our work to where people are, right? We want our work to exist in the world, and in order for it to exist in the world, it has to be constructed out of the materials of the world, rather than purely digital materials.
Thank you very much, Elliot. We're at the end of this
Thank you.
very long day.
Yes.
It was not in Q&A, it was just one question at the very end, but we're looking forward to meeting you outside and in the cool night and looking at your installation. A big applause for Elliot Woods at the end of this day. Thank you very much.